Okay, guys, welcome back. I hope everyone's doing well. The next topic we're going to go through, guys, is enzymes. Really, enzymes isn't too much of a difficult topic. You probably heard about it tons of times in your AS studies where you always talking about enzymes, whether it be the enzymes topic or in relation to other things. And really, in the BMAT, it's a similar thing, guys. It's not really enzymes alone, like sole enzymes questions are never really asked. There's from the more recent papers, I can only find two, which is the ones we're going to be going through. Generally, enzymes are found in relation to other things. So the digestive system, as we're going to go through when we go through the homeostasis topic. So hopefully, guys, you stay with us till then. But for now, guys, let's go through the enzymes questions, the sole enzyme questions. So the first question, guys, is BMAT 2016, which is question 9. So it says the following statements are features of an enzyme from a healthy human, and it says which enzyme has these features. So, guys, pause the video, give yourself a minute, and be sure to come back after that minute so we can go through the answer. Okay, guys, let's look at this question. So it says the following statements are features of an enzyme from a healthy human. Okay, and then it's saying it works at an optimum pH below 4. Right. So what is this? So so remember, 7 is neutral. So if it works at a pH below 4, that means this enzyme works well in acidic conditions. And really, guys, there's only really one main enzyme you probably come across that works well in acidic conditions. That should immediately be popping into your head. The protease is in the stomach, right? Obviously, in the stomach, you have acidic conditions. Uh, the main important reason for that is to kill bugs, obviously. And that means, obviously, the enzymes that work in the stomach also have to adapt well to that environment. So, but let's go through the other options anyway. It digests a substrate into amino acids. Now, at this point, guys, you probably definitely got your answer. So since it breaks down into substrates, that means it's breaking down proteins, and the thing which breaks down protein is protease, right? So protease, as in the protein part, referring to protein, and A's referring to enzyme, and then it works at an optimum temperature of approximately 37. Yeah, most enzymes in the body, if not all of them, work best at 37 body temperature, isn't it? So yeah, so we're basically looking for a protease in the stomach, isn't it? Without me even looking at the answers, and yeah, and we got that as option F, right? So hopefully, guys, that all made sense, and we look forward to seeing you in the next question. All right, guys, so welcome back. So in the previous question, BMAT 2016 question 9, we looked at this question to do with enzymes. Hopefully, it didn't cause too much difficulties. If anything, guys, this was probably more linked to the digestion topic. This is what I mean, guys. So with the enzymes, it's normally linked in with the digestion topic. But anyways, guys, let's move on to the next question, which is BMAT 2013 question 5. It says the action of which enzyme could decrease the pH of a mixture of carbohydrates, proteins, and lipids. And then you have a few options. So, guys, pause the video, give yourself a minute, and be sure to come out after that minute where we'll be going through the answer. Okay, guys, welcome back. So, this is a mixture which has carbohydrates, right? Proteins and lipids. So, the carbohydrates is going to be dealing with the carbohydrates, isn't it? So, the carbohydrates is basically going to break down. So, remember, carbohydrates are essentially just it's basically just sugar, isn't it? So they're basically polymers of sugar molecules such as glucose, galactose, and fructose, right? So a carbohydrate is basically going to break down that large polymer into smaller chunks. So you're basically just left with for example, di-tri plus saccharides, right? You probably heard of that word in your A-level studies. Saccharide just means sugar units, so 3, 4, 5, something like that, sugar units, right? So here this is just gonna form sugar units. So if you add carbohydrates, it's going to deal with the carbohydrates. It's going to not do anything with the protein lipids because obviously those substrates have a different shape to the carbohydrates, and therefore the active side of the carbohydrates is not going to recognize it, but it would recognize to the carbohydrates, and then that would form sugar units, right? But would that decrease the pH? No, sugar units they're not acidic, isn't it? They're a bit polar because they have OH and stuff like that, but they don't provide hydrogen ions, therefore they're not acidic. So it can't be this one. The next one, protease. So protease is going to find its friend, which is the protein, and then it's going to break it down into probably not yet into amino acids, into again like di, tri, plus peptides, right? So 3, 4, 5 amino acids, something like that, right? But the idea, obviously, the idea here is that you can be you're going to get amino acids, right? So even so, you're going to get the groups that are present in amino acids. So let's just say, for example, you get you're going to get like something like that, right? Then you're going to get CRH, and then you're going to get a bond. So let's just say it breaks it down into a dipeptide. You're going to get something like that. CRH, C double bond O, and then OH. But you're going to get quite a few of these, isn't it? So can you see, guys, you have quite a few carboxylic acid groups then, and this can obviously donate hydrogen ions, and therefore that can make your solution acidic, isn't it? So this is correct. And then the lipase is going to find its friend, which is this guy. And then the lipase is going to break down the lipids, isn't it? And what are lipids made of? Is made of um, lipids, i.e., triglycerides, made of glycerol and three fatty acids. So if the lipase breaks down the glycerol from the free fatty acids, generally, actually, what it does is you get the glycerol coming off with one fatty acid, so something like this. So you get like a this is so normally it's like this, isn't it? Normally it's like this triglyceride. So tri because you have three fatty acids, but generally what it does is it breaks it down into a monoglyceride, right, and two fatty acids. But that still the idea still exists is you have fatty acid, right, which is these guys, and these have the COOH group, such as what we saw for the amino acids over there, and therefore that's going to donate hydrogen ions, and that's going to cause the pH to decrease. So this can also do it. So guys, the options is going to be 2 and 3, which is going to be F. So hopefully, guys, that wasn't too problematic. Hopefully that makes sense. And we will look forward to seeing you in the next topic, which is going to be different from it. This was really short, guys, but hopefully it was useful nonetheless. See you soon, guys.